Subscribe to AmpCode and ring the notification bell to get the latest content.
So basically, as you already know that using the Python with Apache Spark is nothing but capability to use the PySpark API, which is built for Apache Spark to able to work with Python language. So basically it uses the py4j Java library. So it needs the communication between the py4j and the JVM to able to convert our Python code into the Java function. So basically it can come with many communication overhead between the py4j and the JVM. So this is how it was expected, and it was the case earlier where the Python was struggling to get a good performance if we compared it to the native Apache Spark language, which is Scala. So the code which is written in Scala was way more efficient than the code written in Python while processing the same amount of data. But things have changed now, and in many scenarios the code which is written in Python and code written in Scala is having similar efficient performance. So it totally depends on the amount of data that you're handling, the type of deployment mode that you have, as well as the capability of your worker nodes and the available memory. So let's talk about some of the optimization techniques that you can utilize to improve the performance of your PySpark applications. So the first one is very surprising, using the data frame or dataset over RDD. So you may ask, but RDD is nothing but a Spark core API, right? So RDD should be more optimized than data frame if we think about it theoretically. But in real world scenarios, RDD is pretty low level, and as well as it will not provide the most efficient plan for many operations. So that's why data frames and dataset have taken the Spark by storm, and everyone is using data frame or dataset right now because of their versatility, the ease of use, because data frame operations are pretty simple to implement. So anyone who know Python can easily work with data frame because the syntax is more or like similar with the pandas. So if you know about pandas, you can easily work with Apache PySpark. So that's why data frame has a good edge above the RDD. And if you talk about the performance itself, many operations are more efficient in data frames as compared to the RDD. So if you are working with PySpark especially, then choose the data frames only, because handling the structured data is way more efficient if we compare it to the RDD in case of the data frames. So the first technique is pretty simple for you. You just have to use the data frame instead of RDD. The second one is you have to avoid the user defined function. So because as you already know that when you apply any transformation on top of the data frame, it is not getting calculated at the time. It only works and processes the data once you call an action. But under the hood, Spark is creating the most efficient query plan so that you're able to get and process the data very efficiently. So that groundwork is not suitable for UDFs, because the functions you have defined, Spark may not able to get the most efficient plan for those functions, and it will suffer vastly when you're dealing with the big data. So you should definitely avoid the user defined function wherever necessary, because Spark's native functions are more suitable and more optimized for your operations, and Spark knows how to optimize that operation using their own native transformation and the actions. So that's why you should avoid UDFs wherever possible. So the next technique is disabling the debug and info log level. So basically Spark uses the log4j library for publishing the logs to the console or in a directory. So basically these log4j logs have many levels as per their severity. It is debug, info, as well as warn and error. So basically debug and info are pretty suitable for debugging your application as well as getting the all info of your Spark application. But if you are working with a huge file having like processing the large data set, it will not be that much efficient, because it will generate a lot of logs and it will have the overhead on the Spark application. So instead you should disable the debug as well as the info log level, and instead only have the warn or error, because that will be sufficient for error solving and the root cause analysis of your application. And then we have the most important optimization techniques as use the smaller script and also having the multiple environment in the PySpark. So using the smaller script is very good because it will have like the maintainability and you can easily optimize the smaller script instead of the more complex one. So if you have a complex script having multiple stages, you can split that up into the smaller script which is more focused and way more optimized than the whole set. So that's why you should focus only on the smaller script and avoid submitting the large and complex workloads on the Spark cluster. And also having the multiple environments like the R&D environment, the QA environment, as well as the development environment. It will reduce a lot of groundwork on the PySpark cluster, and you can also limit the amount of memory each Spark session has for each users which is using the pool of the cluster. So that's how you can easily manage the resource allocation and the available memory in the multiple environments, and you can prioritize the production over QA and R&D. So because that is a live application and it needs the more resources and more fault tolerance than the other environments. So that's how you can use it for optimizing your Spark workloads. And the last one is having the right number of partitions and the partition size in PySpark. So it totally depends on the amount of data you're handling, the type of operations that you are providing and while processing that data, as well as the capacity of your cluster. So basically the thumb rule is like having the more partition with smaller size will be way more efficient than having the less number of partition of the bigger size. So that's how you have to remember that you are having the optimum number of partition to your data frame. So if you are creating a data frame, just try it out and see what would be the best partitioning strategy for your data frame, because having the number of partition varies a use case to use case. So it totally depends and boils down to the amount of data that you are handling as well as the type of transformation you are applying on top of that data frame. So this is how you can experiment it and calculate the most efficient and optimum partitioning size and number of partition for your PySpark data frame.
So that's it for today. I'll see you in the next lecture.